Thank you. I'm Mr. Lehner, and welcome back to Mr. Lehner's Math Extravaganza. In today's webisode, we're going to continue to build on what we've talked about with parallelograms, triangles, and trapezoids to work with the coordinate grid up here. Again, using our x-axis and y-axis to help us determine what these figures may look like. Now you may be asking yourself, when do I ever need to use the coordinate grid? When do I ever need to use trapezoids in some of these shapes? But you'd actually be surprised. With the advances in technology that we have today, a lot of computer programs use coordinate grids like this to actually design buildings, to design rooms and houses, different projects like books and shelves, different types of designs. So when you see those designs, this is actually what they use to do this. You want to be precise. Again, if I was building a building, I need to make sure that my measurements are exact as I'm going to build them. When you think about the classroom, like a desk, they use precise measurements to create a desk, a bookshelf in here. We have a trapezoid table in this classroom that's actually built to specific parameters in here. So you may think that this has nothing to do with math and you're never going to use it again, but if you like technology like me or you like to build things, you can use this to actually make your parameters exact. Well, enough of me talking up here. Let's take a look at figure 1. Okay, in design 1 up here, the first thing that we're going to do is we're going to give a description of what this shape is. When I look at figure 1 up here, I notice that this is definitely a parallelogram. So I always make sure I spell this. This is a parallelogram. Okay, so I know that I look at figure 1, I know that it's a parallelogram. Okay, the next thing I'm going to find is the coordinates of the vertices. Well, what are vertices again? Oh yeah, they're kind of like where two lines kind of meet and they make a point. So that's a vertex, there's another vertice, and a vertice. It's important that we label these vertices so that we know what points we're talking about. So, I'm going to label it this one vertice A, this one vertice B, this one C, and this one D. So when I refer up here to figure 1, this is it's a polygon, but it's a parallelogram A, B, C, D, and I can use that to refer to it. So I'm going to find the coordinates. Again, here's A. So I'm going to put A, I'm going to find the coordinates of A. X-axis is at the bottom, so I'm going to look. Here's that point, that's 2, because that's the x-axis. And I'm going to go up, and it's at 8. So the first one, this vertex is at 2, 8. Let's take a look at B. Okay, so I said vertex B is here. So if I follow this line down, that's at 3. Again, I know what this is 3 because it's halfway, this line is halfway between 2 and 4. So some of you might decide to even label that on there as well. So the first one was 3, and this is going to be 11. So it's 3-11. C. And again, I'm kind of jamming my numbers in here. Vertex C is at 7, 11. Ooh, 7, 11. And then lastly, D. I'm going to try and jam D in here. When I look at vertex D, I notice that it's at 6, and it is 8 across. So it's 6, 8. So I labeled each one of the coordinates of the vertices here using A, B, C, and D. Excuse me. The next thing I'm going to do is look at the side lengths using the coordinates. Now, I'm not using a ruler, I'm not measuring it any way that way. I'm just using my coordinates to try and find out, well, what sides of this parallelogram can I find? So let's look. When I look at the top of this parallelogram, this is side BC. I know that B started at 3 and it ended at 7. So the difference between these is 4. So I know that this side length of this top one, I'm going to call it side BC, is going to equal 4. I know that A and D, this is going to be equal, but I'm going to double check it. A starts at 2, D is at 6, so the difference between 2 and 6 is 4. So side AD is going to equal 4. And again, these two are congruent sides. Now, when looking at side C and D and side B and A, it's a little bit different. If you notice, these sides are on a diagonal. When we found area before, we drew out our handy-dandy little right angles in here, and we drew our triangle. If I was doing that, I'd have 1, 2, 3. I can label that as 3. But what does this 3 stand for? Hopefully you got it at home. The 3 stands for the height. Remember, the height's going to help us when we find the actual area of the figure, but does it tell me the side length of BA? No, it doesn't tell me that side length. So, with the diagonal lines, I'm not going to be able to find out the size of these two sides. I know it's going to be bigger than 3 though. It might be a little bit bigger than 3 because if I took this line and I straightened it out, it's going to be taller than the height. So I can only tell you that side A and D and side B and C are going to be 4 lengths using the coordinates. I cannot use the coordinates to find this diagonal line. If I had a ruler, I could measure it out, but again, we're just trying to use the coordinate grid here. Okay, I'm going to stop there. We've done a lot of work with area, so I'm going to leave the area on its own for right now. What I want you to do at home is to take a look at figure 2 in here. And I want you to describe what type of shape it is, find the coordinates labeling it, the vertices, then try and see if you can find the side lengths of our second polygon here. Go ahead and pause that video and we'll see what you come up with. Okay, you may have noticed, I'm hoping I'm spelling that right. It's a trapezoid. So in figure 2 up here when I look at it, I notice that that is a trapezoid. Okay? Now, you may have labeled this one a little bit different than I have, but make sure you guys can see. I'm going to label this as A, B, C, D. And if you label it differently, that's okay. Just look at where the points that I put it. So I'm going to say that A is going to be at, this looks like 7, 7. So A is 7, 7. B is going to be at 8, 9. C is going to be at 10, 9. Ooh, a little sloppy in these boxes here. That's 10, 9. And then D is going to be at 11, 7. So D was 11, 7. So again, I labeled my vertices A, B, C, and D. I went to my x-axis first, my y-axis second to label the coordinates on that grid. Okay, side lengths. B is at 8, C is at 10. The difference between that is 2. So I could say side BC is equal to 2 centimeters. I can look at AD. Side AD starts at 7, ends at 11. The difference between those two is 4. So side AD is going to equal 4. Now here comes the problem again. When I look at side CD, it's a diagonal line. To find the area, you may have drawn out rectangles before, or I could have drawn out the side here, and I could have drawn out a side here. But this line down the middle again is going to tell me the height. So if I found out that the height was 2, that does not tell me the size of the diagonal line. So I cannot tell you the side length of that trapezoid because it's a diagonal line. Again, if I was going to find the area of this, just like our other strategies, I could have drawn my box around, found the area of the inside square, find the area of those two triangles, and then minus the triangles off on the side. We had different strategies. But again, the main thing I wanted you to be able to see is how we labeled the vertices. How do we determine where to put our points using the x and the y axis? And then also when looking at our figures, how can we use our points here of the vertices to find side lengths? Hopefully with your figure at home you had something similar to what I came up with. If you'd like a challenge, go ahead and try figure 3 and figure 4. They're triangles, and see, can you find the side length of the triangle? Can you find the area of those triangles? Can you label your vertices? And then specifically, what kind of triangles are they? Are they just triangles? Are they a specific type of triangle? But you can go ahead and try those at home as well. Thank you for tuning into Mr. Lehner's Math Extravaganza. As always, we'll see you next time.